So following on from the previous video I did on the Andromeda Galaxy of somebody's third-party data, i.e. the image was not my own, I've been asked to give a run-through using two different people's data for the Orion Nebula, or M42. So what was interesting on these two is it's the first time I've used StarTools on M42. And I was quite impressed again, with StarTools of what it was capable of. And I think StarTools, it does feel a little complicated to use to begin with, but once you have a basic workflow, which hopefully I'll run through here, it is quite quick to actually create an image that looks good and allows you to easily see just what data you actually do have in your image to start with. Again, there's other tools out there such as PixInsight or Photoshop or GIMP, but I think they require a lot more manual manipulation, such as curves and levels, whereas I find StarTools is very good for, I guess, self-calculating or, mathematically calculating based on your data set or based on your image itself. So it's as I said, once you've got the workflow down, you can get through quite quickly. However, StarTools is powerful enough to allow you to adjust parameters and be a bit more specific as you go through over time. So we're going to start with the first data set. I don't know what sources it came from exactly. But I'm just going to open this as a single shot color or DSLR image. And let's see what we've got to start with. Okay, so per usual, the stacked image is very, very dark. That's to be expected. We're going to run auto develop on this. And this is StarTools, where it calculates a stretch. And we can see what we are starting with. So quick glance, the edges look good. The nebula is quite strong in the center there. Stars look tight and focused. So let's, with auto develop per usual, let's just keep this and move on. Okay, so the next thing we're going to do is we're going to use the bin functionality, which reduces the resolution but increases the signal ratio. So this is a high resolution already, 5000 by 2900, which is a lot higher than what you need if you were just going to do use this as a desktop picture or a background picture. I'm just going to scale this down a little further, about 45–46%, and we end up with a new resolution of just over 2000 by 1300, but the signal to noise ratio is improved by 1.48 times. So I think that's a good trade-off for reducing the resolution but increasing the signal within the image. Keep that, and I'm just going to crop the edges next. Doesn't look like it needs too much cropping, but for the sake of workflow completion, I'm just going to use the cropping tool so people can see how that's used. So we'll drag the area that we want to keep, and then at the bottom we could adjust these more finely, pixel by pixel if needed. But I'm just going to try and reduce the top one a little bit just so we can get that last star in here for the sake of it, but otherwise just going to keep that crop. Okay, so we'll go into the wipe module, and the wipe module, basically you can click on the help here, read the text on it, but basically the wipe module kind of detects any unwanted light, whether it be light pollution that's came through, from your environment, or whether it's light that's been introduced in the optics of the actual camera, or telescope itself. And the usage for this basically is kind of like, I'm just going to go for the basic wipe, but there's other ones, you know, if you've got like vignetting within your image, you might want to use that one instead. But the whole idea of this is basically to try and wipe out and balance out the background to the foreground as well. And any banding, any issues that would have with the background, hopefully the wipe module resolves those. But this image seemed pretty good to begin with. I didn't see any like, you know, dark edges or light edges, but hopefully it's, you know, it's worth running the wipe module anyway. So I've just clicked on basic there at the top. As I said, this is just a run through using, you know, as is parameters, just to hopefully highlight how quickly StarTools can give you an image at the end of it. So I'm just going to keep the results there, click twice. And now that we've done all of the cropping and the wiping and the binning of the image, we do another stretch here, which I always use the manual stretch as opposed to the auto stretch. I just seem to get better results for some reason. So what this is doing, why we're doing this a second time, is after the wiping and the cropping, etc., it's brought out what allows us to bring out further information or data for the image, hence why we do it a second time round. So this again is a little bit, you know, kind of like there's no specific numbers on this one. It's a bit of eyeballing it. If we go too low here on the digital development, you can see it's just going to be too dark. However, if we go too high here, obviously it blows everything out and it becomes too light. So still a little bit too dark. If you wanted a really, really dark background, this might be a good choice of around 93 for this image. Whereas I'm just going to subtly increase it a little bit higher. You can see here, the higher I go, the nebula becomes a little bit stronger. However, as I said, we don't want to go too much to where it's too exposed or overexposed. So let's just go about there. As I said, using StarTools, over time you get a better eye for what it should look like here, even though it's not in color at the minute. So 95.88, going to keep that. And then the next module is the HDR module. Now, just to call this out, I'm using one of the latest versions of StarTools. And this, I think in this version, the HDR module, high dynamic range module, it came with a tame option or set of parameters, which basically it pulls out the details from the midtones and the highlights, which is, you know, what we've got a lot of in this image, as opposed to reveal core. We would use that maybe if we like on the Andromeda galaxy, where we do have a solid core in the middle. So anyway, we're going to run the tame settings. Another one for this might have been to try the equalize settings, what pulls a little bit more out of the shadows. But in a test I did before with this image, the tame option of parameters I felt was the best. So just give StarTools hopefully a few seconds to sort itself out. As you can see in the bottom right hand corner, it's thinking about it. So one of the reasons why the tame module is good for this specific M42 is that it doesn't brighten up the core within the object. So why this matters for the M42 is obviously this area here in the middle, it's very easy to blow it out, as in to make it too white or too bright compared to the rest of the object or rest of the image. So the tame balances everything out, I suppose, a little bit better than just run an equalize, where equalize might pull out too much brightness and therefore pull out the core as well, or blow out the core, I suppose. So I'm going to keep the default settings there. So the next module we're going to look at is the Superstructure Module, and this allows us to manipulate large structures within the image, which is certainly what we've got within the M42. And what this does is it emphasizes the structure itself while slightly pushing back the star field. So in this image, what we're interested in is certainly the nebula itself as opposed to the stars. And this does help make the nebula pop a little bit more. So I'm going to use the dim small setting. So dim small basically pushes back anything that is not the superstructure, but it keeps the strength of the data of the superstructure, as I said. So that's why it pops out a little bit more. And next thing we're going to do is start bringing some color into it. Now, obviously, there's other modules here that we could work through. It's just a case of trying them, seeing if they actually do anything for your image or not. But in this video here, I just wanted to go through a workflow using 3 or 4 of the modules. So to the color module now. So what we'll do here is we create a star mask, and you'll see why in a minute. Okay, so it's automatically created the star mask for us. We keep that. And when we go into the color module, we are going to use sample. And what sample does is it looks at the mask, which is the actual stars. And from that, it can set the color balance or the white balance, or takes a white reference point, and from there it can build up the rest of the color for the image. So click on sample, and next thing we want to do is apply those settings to the rest of the image. So we just clear the mask, invert it, and then the entire image is selected, and the entire image will have the color automatically applied to it. Okay, so again, sometimes images a little bit too much green. You can use the sliders here to reduce that out if you want, but otherwise we've just let StarTools do its own calculations, and I think that's pretty good for the colors that have came through on it. And it's, again, the M42, very colorful nebula. We've been, lucky not to blow out any of the core areas around here using the Superstructure Module. And obviously, yes, we can still see some of the star fields, but the stars don't detract from the actual nebula itself. Okay, so we're just going to keep that. And the final thing we're going to do is run the noise reduction. So by removing the tracking, so the tracking is just, allows us to go back several steps if needed. But as soon as we remove that tracking and run this noise reduction module via just selecting this grain size at the bottom. So what we're looking for here, again, no specific number, but if I put it as low as we can, the image doesn't look too different. But if we put it as high as we can, it's very, very, out of focus. And what we're looking for here is the point at which it just goes out of focus without going out too much. That's the way, what I'm looking for when I'm doing this. And I feel like that's the, good balance of not having too much noise reduction where everything just ends up smooth, as opposed to too less where we still end up with the noise in the image. So it's one of those things where, again, it's a bit of, using your eye to see what works and what doesn't work. And I'm just going to pick an area here to zoom in. Let's try and get some of the dark background as well as the nebula. And before, so I'm not sure how well this comes out on the video, but this is a before and this is the after. So again, subtle changes, especially around this dark area where the nebula starts blending into the background, and then after, a little bit smoother. Okay, and let's zoom out on that. So yeah, and keep that. So hopefully using, a quick workflow, as I said, a lot of the standard parameters we used there, but that's why I think StarTools really impresses me as a processing application on your images. Yes, you can change a lot more parameters, a little bit of trial and error, or reading what the parameters do against the website of StarTools. The help files are very, very good. They explain all the parameters as well. But as I said, a quick run through of StarTools, simple workflow, basic parameters, and this is what this image has ended up with. Okay, so the second data set on M42, we're just going to follow the same workflow as the first data set that we've just been through. And, as I'm doing this, it highlights, again, using StarTools, how you can do a quick workflow on multiple images. And, obviously the underlying data of what you start with matters. But it just shows, StarTools is quite good at replicating good, consistent images at the end of the day once you get your workflow down. So the first thing I've done there is auto dev, which is an auto stretch, allows us to see what we're working with. And on this image here, you can see straight away some stacking artifacts at the top and bottom. For just zoom in there just to highlight what I'm talking about. So if we go down to the bottom, we can see here a little grey where this might be the tracking hasn't been perfect, or tracking's been slightly out. Again, I'm not sure how this image was specifically taken, so we're just going to crop that out this time, specifically getting rid of the bottom and top black bands. Okay, keep that. And then let's have a look at this. So the size of this image to start with is not as high as the previous one, but still high. So we can reduce the resolution down and trade off resolution size for an increase in an increase in signal to noise ratio. So just going to drop this down a little bit. We'll still come out with a relatively high resolution, 1900 by 1200. Keep this. And then we're going to run the wipe module per usual. Just going to use the basic settings again on this one. Let StarTools do its thing. Okay, we're going to keep that and then re-stretch or redevelop the image, as StarTools calls it, bringing out or using that new signal, new data that we've pulled out based on the wipe module. So redo this. And again, we're looking for this balance of, if it's too low, it'll be too dark. If it's too high, it'll be overexposed. So let's just, you can either click through it yourself, or StarTools has got this like home in button, which, it seems to, well, home in on a percentage area. Again, it must calculate this in the background, so it knows it's not too dark and it knows it's not too high. And generally, I use the home in button to find an average. This is going between 82 up to 88, up to 94, back to 82, So based on these averages, you probably get an idea of where you should be looking for. So that's a little bit too dark. We're going to go a little bit brighter to start pulling out the nebulosity side of the M42 itself. And I think we'll stick with that. A good balance between, partially dark background, but still we can see the nebula within the M42 itself, which is good. So we'll keep that. Move on to the HDR module again. Remember, for this object M42, I've just been using the tame parameters. So this kind of brings out the what will be the colors, I suppose, and pushes back and dulls the background a little bit further. So again, as I keep saying, I'm using defaults here just to show the workflow, but you can change the various parameters for each of these different modules. Okay, keep that. And then we've definitely got the superstructure still in this image, and we are going to use the dim small, so that'll dim the stars a little bit further, but this is what makes the actual M42 pop out a bit more prominent within the actual image itself. Okay, keep that. Okay, so we're going to start bringing the color out on it. So again, we'll go to mask, just clear it, auto, and we want an automatic star mask generated for us. So do, and then keep, and then you can see that there's not as many stars in this one, but at least the mask's picked up some of them, allowing us to go into the color module, keep the mask, and we are going to sample based on the mask, which is based on the stars. So straight away you can see the histogram bringing out those colors due to that reference it's created. Back to mask, and we want to clear and invert the mask, so that selects the entire image, and that allows us automatically to apply the reference colors that was taken from the stars across the image. So when we come back into here after inverting the mask, we don't actually click anything. The StarTools is just aware that we've changed the mask and therefore reapplies the settings to the entire mask. Okay, so we're going to keep those colors there, looking good still. And then the final thing is the noise reduction, or grain removal option. Again, we're looking here for a balance of, not too much where everything is, drastically out of focus, not too little where there's not really any adjustment. So just kind of get that balance for where it starts to go out of focus, but not too much. Okay, so let's apply that. And let's zoom in there just to see how the background changes have been made. So this is before, so you can hopefully see on the video a lot of individual black pixelation, and then after, where it is generally smoothed out, and that's due to the noise being reduced within this modular function. Okay, so let's zoom out to see what we end up with. We'll keep that. So two different images there that we've been through. Yes, M42, the Orion Nebula in both images, but one's a lot more, the focal or the field of view is different on the two of them. This one's much more constrained on the actual nebula itself, where the other one was a bit more wider, a wide field. But hopefully this video shows how quickly StarTools can process an image, and then obviously you could go back through, rerun everything, but change the parameters or look at more specific parameters And obviously there's, the short module, etc., which I didn't touch. If you've got too many stars within your field as well, you can use a shrink module, etc., etc. But hopefully this has been another good video for just showing basic workthrough of StarTools. And thank you for the 2 people who supplied their data, allowing me to create these